What do Sony, Microsoft, Yahoo, Kaspersky, Barracuda, TalkTalk 711, the British government, the American government, the Turkish government, the Chinese government, and the Indian government all have in common? They've all been hacked using an attack called SQL injection. Numbers differ depending on where you look for this, largely because people don't want to admit to it. But estimates are that anywhere from 51% on the very low end, right up to 97% of all data breaches used SQL injection. This is an attack that has existed for decades. Is it just me, or are we failing to learn a lesson here because it keeps happening? Right. I'm going to show you how this works, because I want you to know how to protect yourself against it so you don't end up on this list as well. Welcome back to the Pro Tech Show. What kind of website might be vulnerable to SQL injection? The answer is any website that uses a database, which is basically all of them, which is why this is such a big deal. Technically, it doesn't have to be a website. I should say any application that uses a database. But websites are usually the front door on the internet where the bad guys come knocking. A SQL injection attack is centered around the use of the Structured Query Language, or SQL, which I tend to pronounce SQL. It's the language used to talk to databases, but you won't need to be a developer to understand this, as it more or less makes sense in plain English, and I'll walk you through. Incidentally, I have a theory about the pronunciation. I think the pronunciation depends on which database you encountered first. If you started out in the open source world, you probably used MySQL and pronounced it SQL. And if you started out in the Microsoft world, you probably used Microsoft SQL Server and pronounced it SQL. Just a theory, let me know in the comments if you think I'm right. Using this language, you can send instructions to the database. Instructions like, show me some data, or change this data, or just delete everything. Obviously, if you're developing a website, you would never let an end user of that website send their own instructions to the database. That would be a catastrophically bad idea, and yet it's exactly what SQL injection lets them do. Let's use an example. Let's say we've discovered a SQL injection flaw in the internet's most well-known online store. I'm of course talking about lttstore.com. On the real website, they have a search feature which you can use to find products. We're going to pretend they messed up when they created that search. I should stress, this is not real. I am not showing you how to hack this website. I'm using it as an example so you can visualize how this works. I have no reason to think the real website is vulnerable, and if it is, you shouldn't hack it because that's illegal and not very nice. Seriously, don't mess with this, you could go to jail. When we type something into the search bar, the website looks in its database for a product that matches what we typed and displays it to us. Let's think for a moment about how it does that. It's talking to the database, so it's using SQL. The website is probably saying something like this. Select means give me information. Name and price are the pieces of information we want. Products is the name of the table in the database that contains this information. Then we're telling it to only return rows from that table where the name of the product has the text water in it. Anything inside the quotes is interpreted as literal text rather than SQL code. The percentage signs are wildcards that match anything. So it's not looking for a product exactly called water, it's looking for a product with water in its name, like water bottle. The semicolon just means we're at the end of our query. Congratulations, now you speak database. Told you it wasn't that hard. If the developer wrote literally this in their code, then the website wouldn't be much use because all it could ever do is show products with water in their name, so it needs to be adjustable. The obvious thing they could do is have their code send this SQL query but change this bit here to whatever value is in the search box. That way if you type water, it would find water bottles, and if you type t-shirt, it would find t-shirts. Hooray! We've got a working search feature on our website. This would work. There are websites out there doing exactly this. And that's a problem, because that method contains a massive flaw. Let me show you. Let's say instead of searching for water, I search for single quote, semicolon, delete from products, semicolon, dash dash. Why on earth would I search for that? Well, look at what it does once the website inserts that search term into the SQL query. Suddenly, when you put it all together, you can probably see the problem. We've got a search for products, in this case, any product at all, then a semicolon, which means it's the end of our query. Then a new query that says delete from products. You don't need to be a programmer to guess at what that's doing. A semicolon to end that query, and then our two dashes. The two dashes in SQL are the start of a comment. A comment lets a programmer write any old text they want and it'll get ignored by the program. It's not code, it's just a way for the developer to make notes about the code. That means we've got two instructions being sent to the database: a select instruction and a delete instruction, and anything else is just treated like a comment and ignored. The website is going to return every single product to me because of the select query, right before it deletes every single product out of that database. This is SQL injection. I have injected my instructions into the website's program because the developer naively trusted a piece of information that I, a random person on the internet, had control over, and ran it. That example will actually work in some cases literally as I wrote it. Some databases and some programming languages won't let you run two SQL queries back to back like that because it's such an obvious mistake. But there are loads of other ways to manipulate this flaw using the same principle. If you use your imagination, you can see just how dangerous this could be. Apart from just destroying data, I could use it to extract confidential data that's held on the same server, and have it dumped onto the web page with my water bottle search results. Maybe I found a table full of customers' credit cards, for example. I could also change data. Maybe I extract details about the database structure, find where the user accounts are stored, and then tell it to change the passwords to one I know. I could insert my own data. Maybe I find a table that's used to hold refunds that need to be paid out, and I stick my own bank details in, along with $1 million refund. It's difficult to overstate just how bad this is, and there seems to be a never-ending parade of web developers who've taught themselves just enough to get a website working, but nowhere near enough to get it working securely, and they keep churning out stuff like this. So how should you do it? There are a couple of approaches you could take. One that seems like a good idea, but isn't, is that you take the user-entered text and you escape it. This means you look through the text for things like this single quote and you stick a slash in front of it. The slash tells the database, I know this looks like a quote, and ordinarily you would treat the quote as meaning the end of a literal text. But in this case, I want you to treat it as a literal quote character inside our text, and not the end of the text. Unfortunately, whilst this works in theory, it's a pretty bad way of trying to protect yourself because it's very difficult to do perfectly, and you only need to slip up once to have your entire server cracked wide open. In our example, there's more to worry about than what I typed into the search box. There's a whole host of information transmitted by my web browser that I could tamper with, like HTTP headers and cookie values. It's less obvious in the search box, but it's my browser, so I can still control it. And if any of that information gets past the database, that's another opportunity for SQL injection. Let's say our programmer has switched on to this and painstakingly identifies and escapes every piece of information coming from the end user. They're safe, right? No. Let's take another scenario. I'm playing a game online, and one of my competitors is bragging about getting the last mouse mat from the LTT store. I really want that mouse mat, so I plan to steal it. But first, I need to know where they live. I try to use SQL injection on the search box to find their contact details from when they placed their order. But LTT Store's developer thought of this and escaped my search terms. So I try another approach. I sign up for an account myself. Let's say I know this person's username in the game was Jake. So I provide my username as Andrew, single quote, or username equals single quote Jake. No luck because the developer isn't going to trust a sign up form where I can type anything I want, are they? They're too clever for that. So the SQL I tried to inject gets escaped and passed the database as literal text rather than a command. But I'm not done. Now I go to my account and browse the page containing my contact details. I'm not going to provide any input here. There's no user submitted data to be escaped. Or is there? To load my contact details, the website first takes the session ID from my browser, escapes it for safety, and looks up its table of logged in sessions to find my username. It then runs a query against the database to find the contact details associated with that username. You can see the problem. That username stored in the database was already poisoned, and now the website has just run a SQL injection attack on itself, displaying the contact details for Andrew, who doesn't actually exist because that wasn't my username, and Jake, who does exist, so that's whose name, phone number, email, and postal address I get to see. This is called a second order SQL injection, where you inject your own SQL command knowing the website won't run it initially, but at some point in the future, that information is going to be retrieved and reused. And at this point, because it's data from the website's own database, the programmer makes a mistake of trusting it. It's not enough to just worry about user input. You need to worry about any information that might be derived from user input, and any information that might be derived from information that might be derived from user input, and you get the idea. Before you know it, you're playing 4D chess where a single mistake leaves your website vulnerable. This approach is far too error-prone. There are so many possible scenarios, and the attacker only needs to think of one that you didn't. This is why so many websites still get hacked using SQL injection. And in 2022, there is no excuse for writing code like this. There's a much better approach that stops SQL injection attacks in its tracks without the developer needing to imagine and defend against every possible scenario. The answer is parameterized queries. Another name for parameterized queries is prepared statements. They're the same thing. When we write a parameterized query, we don't construct the final SQL command before sending it. We first make a template of sorts. If we go back to our first query, select name and price from products where name is like something. That's the template of our query, but the something can change. So what we do is we send the query like this, with the something still unknown. We say, this is our query, and we'll let you know what the something is in just a minute. Well, not really a minute, we'll send it immediately after. The something in this case is water. What this does is it allows the database to understand the format of the query before the variable parameter, the something, is supplied. If that something contains injected SQL, it's designed to change the query from a select into, say, a select and a delete, then it's not going to work, because the database has already seen the template, and it knows this is just a select query. Every time we're building a SQL query in code and there's a variable component that could change, we parameterize it like this. We don't need to worry about user input or information that is derived from user input. If we always use parameterized queries for every variable we include, then the database always understands what the SQL query was supposed to look like. Even if the parameterized parts of it can change, they aren't allowed to fundamentally change the query into something different. If you're writing a website or any code that talks to a database, parameterize everything. It is much easier than trying to predict every possible attack scenario, and any query you don't parameterize is an opportunity for an attacker to think of something you didn't. Assuming LTT Store's developer has done this like a good dev, they can rest easy. Remember though, this is not just about websites. I don't write websites, although like many I have dabbled with it in the past, but I do write scripts. Scripts to automate repetitive or laborious tasks. Sometimes these scripts might need to access a database, and if they do, and if I haven't parameterized those queries, my script might be vulnerable. A lot of people get this wrong, either through ignorance or laziness, but now that you know, the extra couple of lines it takes to write a parameterized query are an absolute no-brainer to protect you from the most common and otherwise difficult to defend against cyber attacks in the world. If you found this useful, then give it a like and consider sharing it with anyone you think could benefit from it. In the meantime, I've injected the YouTube algorithm with a query for a good video based on your personal viewing history, and I came up with this one, so why don't you check that out next. Thanks for watching, see you next time.